Hi guys, welcome back to my channel, and this is the day 12 of the yesterday bootcamp. I will be starting with the code problem of the day. Mm, Question number 1380, and question states that a lucky number in a matrix and given an m into n matrix of distant numbers, and we have to return all the lucky numbers in the matrix in any order. The lucky number is an element of a matrix that is the minimum element in the row and the maximum in its column. For example, here the given matrix is given, and 15 is the luckiest number because it is the minimum in its row and maximum in its column. And same thing for applied for base 2 and base 3. And we have to ask to the interview what are the constraints. As it given, constraints are m equal to math length and equal to math dot of first row dot length. So mn will be ranges up to 10 power means 50. So and each individual element will ranges 1 to 10 power 5. All the elements are distinct as the question states. So that's fine. So this can be solved in multiple approach because the constraints are very less. At max, it will be goes up to 250 elements. So we can solve in mm, quadratic solution, and cubic solution also will be accepted, and even not polynomial, quadratic. I mean, for loops also will be working. And let's go to the notepad and we'll be discussing the problems in tuition. There are four solutions I will be teaching you today. And this question was asked in last 6 months. This question was asked in 10 times of Cisco. Last 1 to 2 years back, it was asked in Oracle. Okay. Brute force approach is very pretty straightforward. For every element in a matrix, for example, this element in a matrix, enter matrix, we have to iterate throughout an array, and we have to find the minimum out of it of the row, and we have to find the minimum of maximum out of the column. So with the help of three loops, we can able to solve this question by iterating using the three loops, and we can satisfy the condition, check the condition. If it satisfies, we can add into our answer and we can return that. The time complexity will be n into m because we are iterating throughout the matrix, and additionally we are iterating towards the respective row and respective column whether it was satisfying the condition or not. So order of n cube solution, this will work in particular solution, and I will be explaining better approach to optimize that will ask will ask about you to optimize the solution in order to use cubic. We should drill down. We can skip this by adding additional or additional space to it, and we can skip the additional loop. Okay, by storing one array, which means that which indicates all the values, respective values present inside the rows that will be stored. And this will, and here you can see the row will having all the maximum infinities initially, and whenever we encounter the minimum, we are storing there. For this row, what will be the minimum one, please store it here. Similar for every individual rows, and same thing will be followed for the column. I will be creating one column array. Whatever the maximum got in this column, please store it here. Initially, it will be set to minus infinity so that the maximum values will be populated for a individual columns as well. So that we can traverse through this array and we can find the which is the minimum in the row, and the maximum value in the column. So that element will be a lucky number. So that is the simulation approach, the better approach. Time complexity is n square, and space will be we are taking two additional one-dimensional arrays or linear, a minimum of n and m. Okay, and let's go to the code. Here I will be taking the row array, which will consist of all the row minimums, and the column maximum will be stored here. We are traversing through entire the array and storing every time we are storing the minimum of every individual array and storing into the particular main, and we are adding the particular row minimum to this array list. And same will be followed for the column. Every time for every column we are checking the maximum one, and take the maximum out of every column and add it to the column row itself. And at the end we can traverse to the whatever we got, the rows and columns. We can check what was the minimum out of it. Please check that, and then we can add into our answer. That's what the question, and that was the solution for the simulation. It was pretty straightforward, and time complexity is the order of n into m, and the space will be order of n plus m. So we are taking one dimensional. So whatever the maximum that will be considered out of n comma m. And optimal solution, the end you will ask you to optimize this one also. We can avoid the space also. We can drill down to constant by having a key observation on that. Suppose here we have a matrix. Assume that we have a matrix. Inside the matrix, take one element which indicates x. We don't know, and that will be present on the first column C1, and it will be present lies on row 1. So as we can see, it was occurred minimum of the row and the maximum of the column. So this is x is a lucky number. Okay, and later on let's assume that we can take another variable component which was present on column 2 and row 2. Okay, here also the minimum element is y in the row 2 and the maximum element of present inside the C2. Let's assume that. So these two are taken. Let's assume both are lucky number. Whether it was satisfying the condition or not, we'll check that. Okay, and let's take an integer which will be also lying on the row 2 and column 1. Name it as a. Here name a is there, and we can take another example where b is there, having which rise on r1 and c2, so that we can compare these two elements with the lucky numbers to satisfy the whether both are satisfying the given following conditions or not. If not, we can conclude the proof. So whatever I pick the like auxiliary, like arbitrary element present inside the array, that element should be minimum. Y should be minimum to its row, which means that y value whatever taking, this value should be less than the a value. A value should be grow more, and x x indicates that it is uh, it is maximum out of the column. So x should be greater than the y to satisfy the above condition. This is the relationship we got with the help of a, and the equation 2 we can generate with the help of v by taking into the C2 lies on C2 and R1, and same thing comparison will be done for y. This is the column, right? So b b should be less than the y, because as we know that this is the lucky number, so we have to adhere the property y should be greater than the b in the column, maximum on the column y should be, and x should be less than the b. So if you compare above equation with the help of a and below equation with the help of b, if you compare with that, you can see take it a y as a constant equations, and we can equate these two, and we can get an contradictory condition stating that, see, y is less than a. Here what we are saying, y is greater than b, which means that b we have and y we have, a we have. So this is not following the condition. Let me write that. For example, we got b is less than y, and y is less than a. This is the contradicting condition we got with the help of both the equation. If we equate this one and if we equate this two, you can see that y is the maximum of b, y is maximum of b, and here a is maximum of y, a is maximum of y. So this the condition we are getting. But What we conclude, y should be an maximum one, not x should be an y should be minimum of the row and maximum of the column. It should not follow like this. See, when we compare this one, right? X is for example here the row one. If we compare with this, how we are getting x is greater than a, and when we compare b, right, x should be less than b. Nothing but x should be less than b. Here you can see a is smaller in range and b is smaller in range. So at the worst case, we can't get the two lucky numbers present inside the array. That is what the condition. For example, if we take here example, if we take some value, 15. Let's take an example of 15. Where is that? Where is that? Let's take an example of 15. 15 was present here, which is the maximum in the column and minimum in the row. In this row, 15 is the minimum, and in this column, 15 is the maximum. So, if we take any element, like suppose A is indicating 8, okay, where 8 is there, and B will be pointing at somewhere at here. Suppose, yeah, this is B. If we compare that, how we are getting B 17 is more than Y. So let's take this as an Y, and Y, and this particular Y is more than A. Okay, which means that this condition, not this condition we are getting. Either one should be satisfying, other one is failing. So that's the reason we can conclude only one lucky number present inside that with the help of this proof. I hope you got it, and please watch it again to understand more clear. And let's go to the infusion of the algorithm. We are taking n is the maximum row size, m is the column size. We are taking initially will be roaming, and we are iterating to entire row, entire matrix, and picking the row minimum and row minimum max value. Why we are taking maximum value in a row? If we have minimum of maximum among those, we can pick and we can store it in here in this variable. And same thing will be applicable for the column max min. Initially, we are taking the maximum values of all the columns, take all the maximums, and on the top of on the maximums, column maximum, take the minimum out of it. So column max min. So we are taking minimum of all the maximum among those columns, and we are checking if both are matching. Then this is a lucky number, and we can return that. Or else, edge case there is no lucky number, we can return an empty array. Time complexity is n into m. The space complexity is constant. I hope you got it, the question and intuition, everything, the four approaches, and I will be explaining daily DSA problems, both GFG and liquid platforms. As you can see, all the visualization, everything was been explained. The graph visualization, dry runs, everything, graphs, trees, and all stack problems, all even pictorial dry runs and image explanation, everything was explained. Please support us, like, share, and subscribe to my channel. And that's